Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott. We're glad you're with us. If you have a math question, please give us a call. If you're here in Bakersfield, the number is 636-4357. If you're in San Luis Obispo, you can also give us a call. The number's toll free, 866-636-6284. You can even email us your math question if you happen to have one and you can write it down. dothemath@kern.org. You can watch the show online, of course, dothemathonline.net. And if you have any kind of social media, we have accounts on all of those platforms: Facebook, Instagram, YouTube, and Twitter.
Well, you know what? I'm glad because lately the students that have been emailing questions have been doing it on Monday, Tuesday, Wednesday,
Right,
as
good
opposed
timing.
to Thursday, Friday,
Right.
when it's going to take a few more days. So nice work on that. We do have a very special guest in studio. We'll meet that young man in a little bit. He's a 6th grade student, so we'll meet him in a little bit. We'll be going out to COM, and there's a lot of things going out of COM these days.
It's a busy place.
They have some new attractions, not like rides and stuff like that, but I mean, as far as a zoo goes, a pretty new room, and I think we're going to check out some of that today. Also, I bring up COM because for all of the students that phone in today and the next 2 weeks, you phone in and we do your math problem on air, you'll automatically receive yourself some tickets to Holiday Lights at COM. So that's not a bad deal right there. If you ever had the opportunity to go out and see Holiday Lights at COM.
Oh, yeah, it's amazing. Don't they say 2 million plus lights there? Is that right?
You know, I remember when it was like whatever million and then it increased and now it's millions of
millions
lights.
of lights, yeah.
Like when McDonald's was so many sold or whatever, now they just put billions on there.
Billions and billions, yeah.
But I think now it is, we're hearing
up to 2 or
that it is
3,
3
yeah.
million.
3 million.
So 3 million
That's a lot
different
of
lights.
lights.
And some of the displays remain the same because they're favorites, but then they also mix in different ones and get a little new and things like that.
Sounds like the goal is maybe to be seeing it from space at some point, right? That's where they're good. That's where they're headed.
Why not? Especially through our fog, right? You know,
Right,
there's
there you
going to
go.
be enough lights to get through that thing.
Yeah.
Anyway, we do have a very special contest going on for a couple of schools over in San Luis Obispo County as well. Those 2 schools are competing, and they have been competing for a couple of weeks to find out which school can phone in the most during that time period. And the end result will be if there's a school that outperforms the other, they will have some of their students have the opportunity to go to Doc Bernstein's Ice Cream Lab secret facility headquarters, right, where they make all the goods and be able to have a private tour of that brand new facility over on the Central Coast. So that's something big coming up. Anyway, before we get to the phone calls, our special guest of the afternoon, let's first take a look at today's Math in the News. So yesterday we were talking about how there are a lot of advertisements coming in your mailbox now, especially for catalogs and things like that.
Tis the season.
Tis the season to get the recycle thing filled up even faster, right?
That's right.
But anyway, we were talking about one where it was 75% off. I think it was. I think we've still got it here. Yeah, save 75%. And I was looking at the price, and it was 75% off the original price. And I go, well, it seems pretty close, so let's just do it.
Sure.
And it was a cent off.
Aha.
And they have an asterisk there, and that's kind of, but the way they did it, it made everything rounded to seem more like 75% off instead of 74.8% off, and then having $49.99, which a lot of people are used to seeing things with 99 at the end.
Right, right.
So that was yesterday, and then I was talking to some junior high kids and talking about mathematics and some math problems and puzzles and things like that. The not ordinary mathematics that you would do in a classroom.
Okay.
So this one today has to do with a birthday.
All right.
Now, do you have a birthday coming up? I don't even know what your birthday is.
Just passed, right around Halloween.
Just passed.
Just passed. I was nice and quiet about that one. Worked out pretty well.
Was it a big one or something? Was it a monumental?
It was a wonderful birthday. That's all we have to know about that one. I think I might have been on the show that day.
All right. So we'll leave it at that. So a lovely birthday cake right there. Was yours as nice as that? A little nicer? Do you not even have a cake?
That's pretty nice. That's a pretty nice cake. I did not have it quite that nice.
No, I don't have cake like that either. I'm not a big fan of frosting anyway, so it would never look like that. But anyway, so I found this math problem. The last two numbers of my birth year are the same as my age today. How old am I? All right, so we're going to sit and ponder this for a moment, all right? So think about what you just turned, however old it was, all right? It would be very funny if you turned the age and you were born in that year,
right.
And I'm bringing this up just out of the blue today, and it happened to be,
I
is
don't
your
think that
birth
quite
year
works.
the same?
No.
Okay, so.
No, I'd be a little older.
All right. So here's an example. If you were born in 1970, you would be 70 years old in the year 2040. All right? So we're going to take this slow for kids going, oh, what are you getting at here, right?
Okay.
So if you were born in 1970, now you take the last 2 years of your birth year, 70, you would not be 70 until the year 2040.
Okay, that makes
all right?
sense.
So the last two numbers of the birth year would be the same as your age. So we want to know if somebody had their birthday today.
Right.
All right?
Okay.
How old would they be? What year were they born? All right? So do you have an idea of how you might go about this?
Well, let's see.
I know I'm just throwing it out there at you.
Yeah.
But that's the beauty of live TV too, right?
Right. What have we got? 2018. So
let's take a look
that's a
here.
rough one.
Right. So since it's 2018 right now, we have to find numbers that will double to end with 18.
Okay.
Right? So we need numbers that if you're going to double it,
right,
it's going to end in 18. The only numbers would be 9 and 59. Okay? Since there are two numbers in the age, the person cannot be 9.
Right, okay.
All right? Because they go, well, I was born in 2009.
Right.
And you double that, you get 18.
Right.
But you don't have two numbers in your age when you're 9.
Right.
So the only other number would be 1959, and you would be 59 years old today.
Nice.
Because if you took the 5 and the 9,
right,
you have your 18.
Yeah.
Okay?
Yeah, a little bit
because
older
then
than
I was thinking, all right, so somebody might go, well, what if I was born in 1979?
Right.
Well, if you were born in 1979, you wouldn't be 79.
That's right.
Now. Okay.
The 70s
Plus,
don't work.
the 7 and the 9, if you're not going to get 18 either.
Right.
All right.
Yeah.
So anyway, that is today's Math in the News, a little birthday, and just one of those little puzzle things that are always fun to take a look at. Now, here is another one. Can you think of the largest number that is one syllable? The largest one-syllable number. So let's start at the beginning. 1.
Okay, 1.
One syllable.
Yeah.
Right. 2.
Yeah.
2's the winner so far.
Right.
3.
3.
So let's think of some larger numbers. 28.
I'd say
20.
Right.
So
I'd say once you get over 20, you're kind of in trouble. Maybe 12.
What about 11?
11 doesn't work so well.
Right, because it's not even one syllable.
Right. Right.
Because 12 is the number.
Yeah.
Right. The largest one-syllable number.
Right.
Because once you get into the teens, like 13, any teen is going to have 2.
And then you got 20s and 30s, and after that,
and
100s,
after that, I
and
mean,
then
you're done then.
Game
right?
over.
So nicely done on the
12.
The little.
All right, 12's the
quizzes
winner.
right there. Hey, we do have phone tutors available until 5:30 today, most Tuesdays and Wednesdays throughout the regular school year. Since it is a little bit after Thanksgiving, the week after, we only have 2 more weeks of live broadcast after this week. So if you do need some math help before the semester ends, possibly reviewing something, maybe you know something that might be coming up and you need a little bit of extra help, that's exactly what we're here for. Right now, we're going to go out live to come and visit with Marylou.
We are live today at the California Living Museum, also known as CALM, and we are in a brand new room out here, which is called the Coast Room, correct?
Yes, California Coast Room.
And I am with Andrew Adams. Andrew, can you tell everybody what your position is here at CALM?
Yes, I'm an animal keeper here at the California Living Museum, and I work in this area, the California Coast Room.
Now, this is one of the newest area of CALM, correct? The newest what exactly, when did this open?
Well, we opened in January of 2017 with the jellyfish and the touch tank behind us, and then in the summer we added 2 new tanks, octopus and the seahorses.
Okay, can you kind of tell us quickly, lead us around the room, what are we standing in front of here?
All right, so this here is our moon jelly tank. It's about 500 gallons, and right now we've done a broadcast feed with really, really small brine shrimp, and they're going to kind of absorb those with their tentacles and eat them.
About how long would it take them to digest all that? Or?
So it'll take a few hours, and we feed them twice a day, in the morning and then at night.
Okay, now where do jellyfish normally habitat at?
So they live in all the oceans of the world, the Pacific and Atlantic. These particular moon jellies, this species is found more on the east coast, but there is one that also is on the west coast too, all throughout California.
Okay, is there any particular temperatures or anything that they always have to be between?
Yeah, so these particular ones can maintain a little bit of a warmer temperature, between say 60 and 75 degrees, but the ones on the California coast will be colder, 55 to 65 degrees.
Okay, besides that, let's walk on over here. I love this Mr. Potato Head. Can you tell us what's going on over here in this exhibit?
Yeah, so this is Hank, our 2-spotted octopus, and he likes to live in that little Mr. Potato Head. He's kind of claimed that as his home, as his little den or cave. We added that because before he had that, he would try and pull out the bottom of the tank and cause a little bit of problems.
So he
so he prefers to be in there. Yes, he likes to hide. And he's nocturnal, so he'll come out more at night.
Okay, what is over here in this other tank?
And then here we have 6 northern seahorses. And they like to kind of wrap their tails around the different corals in there and hold on. And Sharon here is going to be feeding them some mysis shrimp, which they get 3 times a day.
Where is their habitat at?
So these particular ones also are on the east coast in the warmer water, but there are some in California, towards Baja California.
So when Sharon's feeding, when you always use the plunger, kind of move it around?
Yeah,
or?
so she's using that turkey baster. We just found that that's the easiest way to feed them because they're not very strong swimmers, and so she's able to kind of get it close to them so it doesn't all just settle onto the bottom, and they're able to actually pluck it from the open water.
So she's getting it right to them.
Yes.
Wow.
They can swim, but they're very slow compared to other fish.
So what is going on over here?
All right, so this is our touch tank, which we allow guests to kind of touch some of the animals in here.
And there's quite a bit inside
yes,
here.
a lot of different animals in this tank here, and all of these animals in here come from Monterey Bay, California.
Is it from the aquarium over there, or
from the actual bay?
Okay. So starting up here, what do we have here?
So we have some California mussels and a rock scallop. Those are alive.
And then down here, because there's a lot of
some
animals
of the animals
hiding.
like to kind of hide in crevices, in darker places.
That's almost like a porcupine.
Yeah, so that's a purple sea urchin. And they're very prickly, but we were actually able to touch them as long as we're gentle. And if you put your finger on it, you can feel the spines kind of close around your finger.
Now, these are beautiful, and I noticed there's lights above. What do these lights have to do with this tank?
Yeah, so these are giant green sea anemones, and the lights here help kind of simulate the natural light from the sun. So they're full spectrum aquarium lights.
And this right here, because you have 3 of these. What
Yes.
exactly are these? And they're
Yeah, so
sticky. Their
yeah,
tentacles
so
are
these guys
sticky.
are giant green sea anemones, and they have these tiny little stingers. So they're actually too small to penetrate your finger, but if a fish were to go in there, the barbs would poke them and then stun them, and they would be able to actually catch them and move them to their mouth in the center here and swallow them.
Now, I know that. Oh, there he is,
So
the
I
crab.
can actually I'll demonstrate that with a piece of shrimp here. You see, he's grabbed it and he's starting to slowly move it into his mouth.
So they take this and they go right here. This is where their mouth is located, and they slowly. How long does it take?
Probably get that all the way down in about 5 minutes or so.
And then over here, right here, we have this lovely.
Yeah, he's a very big decorator crab.
What does that mean?
He's called a decorator crab because he'll take pieces of seagrass or kelp and or things around his environment and actually put it on his body to camouflage himself. And when you touch him, he almost feels kind of like Velcro.
And if you could see right there, oh, that's a cucumber. I think there's a cucumber.
So there's a sea cucumber right here.
That's why I said there's so many different things that are hiding all underneath these crevices. And then continuing on. What a fun exhibit, especially for hands-on for students. When they come in, they must have a ball
Really like it.
exploring and touching everything. Okay, well, we have a lot more to explore ourselves, but we're going to send it back to everybody at the studio. And when you come back, Andrew, I think you do have some kind of math problem for us, yes? Okay, so we're going to send it back to the studio, and we'll see you in a little bit.
All right, thanks to everybody at Com and Marylou right there. 636-4357 is that phone number. We do have phone tutors available until 5:30 this afternoon. Just a reminder, you phone in and we do one of your math problems on air, you will automatically be receiving some tickets to Com to go see Holiday Lights. 3 million lights this year. And that will be starting up, I believe, this weekend and rolling all the way. So it starts on this Friday and rolls basically through all of December.
Yep, and they got a lot of them up because we did a little test drive. We did a little drive-by the other day. Looks good.
And it's January 5th, right before we go back to school again.
That's right.
So a family tradition for a lot of families and people that have other people, relatives, friends coming into town, oftentimes bring them, that's one of the things that they want to do is bring them out to the Holiday Lights at Com.
Yeah.
Actually has been rated one of the premier shows on the West Coast, right here in Bakersfield. And you can go for free. You know what? We're going to have you do a math problem right now.
Sounds good.
All right. Let's take a look at the Elmo right now. We're going to do a little x-intercept. Find the x-intercept and the y-intercept of the graph of the equation 4x minus 2y is equal to 8.
Okay, so just to make sure we're clear about what's going on here, let me give a little side example here. If you had a little graph and you had a line that was on this graph, I'll make that over here in red. What we're looking for is a point that hits the y-axis and a point that hits the x-axis. So before we start, we'd like to think about these points a little bit and what they represent, and not only what they represent, but what the numbers are. So if you were looking at a number that was on the y-axis here, this number would not go back and forth, or this point would not go back and forth at all on the x-axis, and it would go up and down. So this point right here would actually start with a 0. And then you would try to figure out, maybe in this case, it would be a positive 1. The other point that we have here, the x-intercept, right? This is the x-axis. This is the y-axis. The x-intercept has a point here, and it has a number that goes back and forth. Let's say that maybe this is -2, but it doesn't go up and down at all. It has a 0. So these are really specific points, and the reason that I point that out is because you can see there's some zeros in there. So if we want to find the x and y intercept of this specific line, then we need to make sure that we find, first of all, the x-intercept. We know that the x-intercept is going to have a 0 for the y value. And the y-intercept is going to have a 0 for the x value. So we can actually fill out half the problem without doing any math. We can actually figure out that we can have half the numbers ready to go. The other half we can use by being able to plug those things in. So it's kind of a neat deal. So here's what happens. I can take this 0 here, since this is in the y place, and put it right in there for y. So watch what happens here. We have 4x minus 2 times 0, and that equals 8. The nice part about 0 is it makes things go away. So this is a pretty straightforward equation. We have 4x equals 8. And if you divide by 4, x equals 2. We can put that number right there. So there's the x-intercept. We can figure out what that is. We'll graph this in just a minute. The same process goes if you actually have the 0 in here for the x, and we want to find the y, we just have to put it in a different place. So it looks like this. 4 times 0. Then we subtract 2y. We want to know what y is. And that equals 8. Again, we have a 0 here, so finding the x and y intercept is a pretty straightforward process. There's not quite as much to do because half of the equation actually goes away. We have negative 2y equals 8. Divide by negative 2, and y equals negative 4. So I'm going to put that way back over here. Negative 4. So I got 2 points now, and all you need when you graph a point or graph a line is 2 points. That's all you need. So if you have those 2 points, we can make a graph. I'll show you how this goes. This is going to be the real graph over here. The other one was just kind of an example. This is the x-axis, and this is the y-axis. So let's graph these 2 points and kind of get an idea what this thing looks like. The point 2, 0 is 2 to the right and 0. Let's say this is 2, 0. And the point 0, negative 4 is back and forth 0, but down negative 4. This is 0, negative 4. And as long as you have 2 points, that's all you need to do, all you need to have to make a line. So we can connect these points, and we have graphed this line just by using the x and y intercepts.
There you go. Nicely done. Thank you. We found x, we found y, and we found Wyatt.
Hey!
Wyatt's in studio with us today. How are you?
I'm good.
Why don't you remind everybody where you go to school and what grade you're in?
I go to Thorner Elementary and I'm in 6th grade.
Everything going good this year?
Yep.
Yeah. What's the best thing about 6th grade?
The best thing about 6th grade, I think, is fireball. We get to play dodgeball
What?
at school.
Explain this a little bit.
In the mornings, every morning we do PE, and we switch off every 3 or 4 weeks to different activities, and my favorite is fireball.
So what's so fun about fireball? Is this dodgeball? I mean, I'm familiar with that, but
Yeah. It just has a couple different rules.
such as?
Such as, like, when you get out, you go behind the other team to get them out, and once you get someone out, then you get back in the game. So until everybody's out, then it's fair game.
Okay, so you like fireball.
Right.
Maybe we'll have Scott go out someplace at the school and participate in some fireball sometime. Anyway, we're going to get to you in a little bit there, young man. Right now, we're going to go to the phones. And Caitlin, how are you this afternoon?
Good. How are you?
I'm wonderful myself, and we do know that you are, I believe this is the Reagan 6th grade Caitlin, correct?
Yes.
All right. As soon as you're ready, let's hear the math problem that you're working on.
What is the volume of a rectangular prism of height 5 centimeters, width 7 centimeters, and depth 3 centimeters?
Wow.
I got a 5 by 7 by 3.
Volume, 5 centimeters and 7 centimeters and 3 centimeters. Sounds good. Caitlin, where do you want to go with this thing? I drew a little picture here if you're watching the show. It's kind of usually how we try to draw a three-dimensional figure, but it's a rectangular prism, is that right?
Yes.
Okay, so I kind of drew a picture there. And tell me a little bit about volume. What kind of units are you looking for at the end of this problem?
Centimeters cubed.
Good for you. That's exactly right. We want cubic centimeters at the very end. So before I even start, what I like to explain to my students is make sure you put the units down first so that after you get done with all the numbers, you don't forget the units, because a lot of times if you forget the units, you'll get the problem wrong. So at the very end of the problem, we're already putting centimeters to the third power, or you can actually write out the words cubic centimeters. Good start. Okay, so where do you want to go from here? How do we find the volume of this rectangular prism?
So I did 5 times 7.
5 times 7. Okay, so we're doing some multiplication. And what's 5 times 7?
35.
35. Okay. What else?
Times 3.
Times 3. Okay. And what do you get
And
there?
I got 105 centimeters cubed.
105. 105 centimeters cubed. Nice job on the volume there. You even have the units. Now, if you change one of these numbers, just one, let's say we took the 3, and you made the 3 bigger, right? You made the 3 bigger. Would it make the volume go up?
Yes.
It would. That's exactly right. If you took one of the numbers, like say the number 7, and you made it smaller, would it make the volume go down?
Yes.
It would. Now here's an interesting question for you. What happens if one of your numbers is a fraction? Would you still be able to do this problem?
Yes.
You could. Same exact way, right? So just because things change, whether the numbers are bigger or smaller or even fractions or decimals, all volume problems of rectangular prisms are done the same way. You just got to multiply those 3 things together. Okay? Nice question. I like it.
There you go. Nicely done. And Caitlin, congratulations for that phone call. You've got yourself a pass to Holiday Lights at Com. So congratulations on that. That's simple. Have you ever been to Holiday Lights at Com?
Yes.
You like that out there?
Mm-hmm.
Do you remember any of the displays that you remember and you're like, oh, I like that one, or something about it?
I like that all the trees always have lights on them, every single tree.
So all the branches and stuff like that, that is pretty cool when you can see the outline of the tree with the lights right there. Are you ready to do a little work?
Yeah.
All right, erase the board. Head on over there.
Black or red?
Black.
Good call.
Now, since you didn't bring any homework with you, as far as I know, I'm going to give you a problem.
Okay.
All right? So what I'd like you to do is I would like you to write down the numbers 1, 2, 3, 4 in a row and put a little space between them. Start farther over on the left.
Over here.
Over here. 1, 2, 3. Good job. All right.
There you go. All right. Now at the end of the 4, put an equal sign. Now I would like you to select a number between 2 and 10.
7.
Put a 7 at the end. I need you to use a 1, a 2, a 3, and a 4 using any mathematical notations, computations that you like. So you can add, multiply, subtract, divide, square root, decimal points, whatever you like.
Okay.
To get 1, 2, 3, and 4 equal to 7.
Okay.
Ooh, should be fun, huh?
I know that 3 plus 4 equals 7,
Okay.
and you can't do plus 1 minus 1.
Yeah,
So-
almost. That's a good start, though. Good thinking. So if you could make this into 1 times 7, it'd be great. But we can't quite do that. Okay,
Right.
keep thinking. I like how you're thinking out loud here.
So we could do 4 plus 1 minus 2 plus 3.
Whoa. Now here's the question. Are we allowed to rearrange the numbers?
They have to say in that order 1, 2, 3, 4.
Oh, got to
Okay.
stay in the order. All right. But you're still thinking well out loud. So what happens, let's start with this way. What happens if you added them all up together?
You would
1
get
plus 2
10.
plus 3 plus 4. That's it. Gotcha. So we can't have 10. We got to have 7. We got to have 3 less, right?
Right.
So what if we just took out the 3? 1 plus 2 plus 4, that'd be 7. If the
Right.
3 was gone, we'd be good. So is there a way to make the 3 vanish? Not that we can think of. Well,
No.
maybe.
Well,
Maybe there is.
there
What
might
if we
be a way.
multiplied them all together? Let's figure out
Well,
what
here's
happens
what I
there.
want you to do. Let's go back to your original idea.
Okay.
All right. You wanted to get a 1 at the beginning with just the 1 and the 2, right? Think about it a little bit, okay? Because you can use any mathematic notation you want. How can you use a 1 and a 2 in that order and get 1?
1.
1 plus
Try
2,
this.
that doesn't work.
Put a negative symbol in front of the 1.
Oh, here we go. Ready?
Okay.
Now,
Negative 1.
if you have
Negative
negative 1
1
and you have a 2,
plus 2 equals 1.
Hey, look at that. Okay.
now
so
you
this part
continue with
right
the rest
here,
of it there.
Negative 1 plus 2 is positive 1.
Positive 1.
Okay. And then what are you going to do with the 3 and the 4?
You're gonna. Can you?
A
Okay,
few things
so
you could do.
Yeah.
yeah,
You told us that you wanted to
add.
add them together. That's right. So we have these ones added together, right? This whole thing right here is now 7. So what about 1 and 7? How does 1 and 7 make 7?
1 times 7.
That's it. You
7
got it.
times.
Good deal. So you probably want to use some parentheses to be able to make sure you do this part first,
Right.
and do that part first, and don't do the multiplication first. But that's definitely one way to do it. I'm sure there are others, but well done.
There are. Nicely done. So I let you choose the number you wanted to come up to. Good thing you didn't say 10 because you just add them all up right there. All right, 636-4357 is the phone number. We do have phone tutors available until 5:30. We'll be back with more right after this. Today we're at Midway School, home of the mighty Midway Tigers, and we're here to... Well, today we're at Midway School. We've got some students from 5th and 6th grade. And a lot of times students, they are doing their math homework, they get a book and they're like, all right, I have to do this problem. You guys don't have to do any problem out of any math book. How's that sound? You don't know what to say to that, huh? You're like, all right, we're not going to do a math book out of a math book problem. What are we going to do? You're going to make up the problem. All right? So here we go. All right. What do you mean, oh no? So this is going to be the easiest thing in the world. You guys get to make the math problem. All right. Boys, here we go. I want each of you, boys, you're going to give me one single-digit number, all right?
6.
6. Let's keep them positive.
Okay, then 4.
4.
7.
7.
2.
Whoa, easy there, sister. 2?
3.
3. All right. So, here we go. We have a 6, a 4, a 7, and a 3. So write those numbers down. And you don't have to use them in that order. All right? How many of you remember order of operations?
Not it.
You remember order of operations?
Been so long.
It's been so long. Well, it's a good thing I'm here today then, huh? So you guys can practice that up a little bit? Okay, order of operations. What's the first thing you have to look for?
Parentheses.
Parentheses. Right? Then what?
Oh, I remember.
Exponents. Multiply and divide are both the same. Right? Multiply and divide, and then what?
Add and subtract.
Add and subtract. Right? You guys remember hearing, please excuse my dear Aunt Sally?
Yes. Yes.
See, that's made it all the way out here to Midway School too, huh? All right. So, what you're going to do is use the order of operations. So you can add, subtract, multiply, divide, use parentheses. I don't know if I would use any of these numbers as an exponent because then you're going to get a really large number, okay? So girls, I want you, because you're in 5th and 6th grade, I want you to decide, is the number going to be 5 or 6?
5.
5. All right. So you have to use these 4 numbers and you have to make some sort of an equation using order of operations to get an answer of 5. You ready? You think you guys can do it?
Yeah.
I'm going to give you 3 minutes for anybody to come up with the answer of 5. Okay. Set? Go. Remember, you can put the numbers in any order you want. They don't have to stay in that order. Multiply, divide, add, subtract, use parentheses. What other mathematical symbols could you use in this? You guys think of anything else? What about a decimal point? Oh, okay. What about a radical sign? You guys been introduced to that yet?
No.
No.
Check this out. You guys ever seen that symbol?
Yes.
Oh, yeah. What were you telling me no then for? All right. So what's the square root of 9?
3.
Don't be messing with me. You guys know all about this already, don't you? All right. So if you did something like this, you could change the number 4 into a, what's the square root of 2? Or 4? Gave you the answer already, right? 2. So you could turn that into a 2 if you wanted to using that sign. If you want to leave it as a 4, you can do that also. Easy. See that? I gave you a little clue. You got that already? All right. Keep on working. We're going to check out and see what he's got.
It's very fast. 6 plus 4 equals 10. 10 squared is 5.
Well, you have to use all the numbers. You have to use 6, 4, 7, and 3. Yeah, you have to use all the numbers.
Okay.
You have to use all 4 numbers, 6, 4, 7, and 3. All right, well, the students in 5th and 6th grade at Midway School are working on a problem they came up with. They came up with all the numbers. They had a 6, a 4, a 7, and a 3. They have to use all 4 numbers. You can use them in any order you want, and you have to have it come out to equal 5. So,
I got it too.
you got an answer too?
We got it.
All right, let's take a look at what you guys have.
4 times 3 is 12, and 6 divided by 12 would be 2, and then 7 take away 2 is 5.
All right, so if we go 6 divided by 12, now think about it. So what's 12 divided by 6? 2. So can 6 divided by 12 be 2?
Yes.
That's going to be opposite, right? That's going to be a smaller number. So rearrange the numbers so that you have 4 times 3 is 12 first. So you can rearrange them, right? So you've got the right idea,
Okay.
right? And then put the 7 at the very beginning also, so you're going to go 7 minus 2. Does that make sense to you guys?
Yeah.
You all kind of working on the same thing?
Yeah, kind of.
Right? Because if you think about it, if you have 12 and you divide it by 6, you're going to get 2 for each person, right? But if you only have 6 of something and you're going to divide it into 12, you're not getting 2 of everything now, are you? You're going to get half of something.
Yeah.
So just rearrange your numbers and you've got the correct answer.
Oh, never mind. I messed up.
All right, so you saw what you did?
Yeah.
All right, there you go. Well, you know what? The girls came up with an answer right there, how they rearranged the numbers, and they did come up with the answer of 5 using a 6, a 4, a 7, and a 3. All of that at Midway School. And once again, a big thanks to the staff and students at Midway School. Always have a great time when we go out and visit the different classrooms. We do have phone tutors available until 5:30. We have Wyatt, a 6th grade student from Thorner Elementary, in studio with us. Going to be doing some more work with him in a little bit. But right now, we're going to go back out live to come and visit with Marylou.
We are back live at the California Living Museum with Andrew Adams, and we are in the new Coast Room. And you kind of led us through this, and you have 3 different tanks: the jellyfish tank, and then obviously we have our octopus over there and the seahorse, and then we have the amazing touch tank, which obviously anyone can come into the room and explore, correct?
Yes. Yes, we're open from 10 until 3.
So they can walk in and kind of explore on their own.
Yes, and there'll be an attendant here to kind of talk about the animals too.
Now,
Adjust them.
before we left last time, the jellyfish had just been fed.
Yes.
And it's kind of really cool because you can see it, correct?
Yeah, so you can see all the brine shrimp that they moved to their stomachs from their outer arms, and they slowly moved them up to the little pouches of stomachs there.
So they feed just like the enemies over there, correct?
Yes, very similar.
So they just kind of bring it in with their little...
Yeah, so you see they kind of pulsate and slowly move that towards their stomachs.
And those little pouches there in the center, those are their stomachs.
Yes.
And you were saying it takes a couple hours for them to actually digest.
Yeah, so it'll take a couple hours for that to fully be digested, and we feed them twice a day.
So the main thing here in this room is obviously water.
Yes, lots of water.
Can you tell us, because students might come in and think, well, this is just normal tap water. You turn on a hose and you fill it up. Is that correct?
No, because we're what's called a closed system. We're not like other bigger aquariums that can bring in seawater from the ocean. We have to actually make seawater. And so the way we do that is we start with RO water, reverse osmosis water, which is very pure, and then we add salt to it to make it almost exactly the same salinity as the Pacific Ocean.
Okay, you said a big word right there, salinity.
Yes.
What does that mean?
The salinity is a number that is the actual weight of the salt in the water.
Okay, can you kind of show us, because you have a back room.
Yes.
With all this. Can you kind of show us where that is and
Sure.
kind of run us
Come over
through?
here. So this room here is the pump room for the touch tank. And inside of here, we have our salt reserve tanks on this side, and then the actual pump systems on the other side.
Okay, so can you kind of give us a math problem on how you determine how much salt goes into the water?
Sure, yeah. So we have the two tanks here. So there's the reverse osmosis filter that makes the RO water. And then to mix the salt, we've got to kind of figure out about how much we want. So right now we have about 25 gallons, and we want to bring it up to 35 gallons. So we need to mix about 10 gallons of salt. And then we use a specific type of salt, and the instructions for that salt to get it to 1.025 specific gravity, which is what most of the oceans are, is 1 cup will make 2 gallons. So we have 1 cup, 2 gallons of water.
So it's 1 cup of salt, and this is your salt, correct? This
yes,
bucket?
inside of the bucket, just fine salt in there.
And it looks really fine.
Yeah,
So it's a
very,
special
very
type
fine.
of salt. It's not something that you would bake with.
This is, it's actually called reef crystals, and a lot of saltwater hobbyists would probably recognize it. It's very commonly used in reef tanks.
So we have our 1 cup to 2 gallons.
Yes. So 1 cup to 2 gallons, so we know we're going to need about, let's see, 5 cups
So we need 5 cups of
the
yeah,
reef crystals.
because we'll have 5 cups to our 10 gallons.
Yes.
Okay, so obviously you use proportions to kind of help you fill this out.
Yes.
So it's not just, hey, let's pour some salt in there. It's you have to be mathematical with it.
Yes, we could use more or less, but then it would change the salinity of the water. And so we want to get it very close to that number, which is 1.025 specific gravity, and that's also 34 parts per thousand of salt.
Andrew, what would happen if you were to put too much salt into the water?
If you get it more than, say, 10 points, it could be very, very salty, and some of the animals might even just sit up at the top if there's too much, but also if it's too salty, that could actually damage the animals. The salt will eat at their bodies.
Okay, well, thank you so much on that. And we still have a lot more coming from COM, but for right now, we are going to send it back to the studio.
Thanks for that, Marylou. We do have phone tutors available until 5:30. We've got Wyatt in studio, ready to work. Back to the board, young man.
Here we go.
Choose a mixed number, any mixed number you like. Write it up there.
Okay. 2 and 3/5.
Put a multiplication symbol. 12, and I'll give you a mixed number. So 12 will be the whole number. 12 and 4/7.
Ooh, I like it.
Solve that if you would, please, and explain how you're doing it.
Okay, so when we multiply, what we do first is we leave out the whole numbers.
Okay.
So we're going to put this 12 over here, and we're going to put the 2 fractions down here. And then now we're going to multiply these 2 on the bottom.
Okay.
And since 35 divided by 5 equals 7, we're going to do 3 times 7, which equals 21. And then, so we're going to put this over here. And then since 7 divided by 35 equals 5, we're going to do 4 times 5 equals 20. And then we're going to add these. So, right.
Right. Well, so where do all these numbers come from? Tell us a little bit about this process.
So first, since we left out the whole numbers, this 2 and this 12 are out.
Okay.
So now we're going to be multiplying these 2, and this is going to be the denominator of the fraction.
The denominator. That makes sense.
Right. And since you can't just multiply this right here, because that'd be 12/35, and that wouldn't be that wouldn't be the fraction that it would be if we did it like this.
Okay.
So since we have 41 here, we're going to put 41 right here. And so now, since this is an improper fraction, 35 goes into 41 one time,
Okay.
which would be another 1 over here, which is another whole number that we're going to add later. And then there's going to be 6 left. So there's going to be 6 35ths. And now we're going to add the whole numbers together, and it's going to be...
Now hold on real quick, just to make sure. I like how you said we're going to add this one in at the very end. That makes sense. But what happened to the 2 and the 12? What did we do with those numbers?
We put them over here, so we're going to multiply them.
We're going to multiply them, right? And then at
And
the
then
end,
add the
add one
one,
in?
right.
Okay, gotcha. So we want to make sure that we're multiplying these ones.
Right.
That's what we need to do there. Good, okay.
2 times 12 equals 24 plus this little 1 here equals 25.
Wow.
And it would be 25 right here next to this.
25 and 6 over 35.
Yes.
This method right here is so unique because you can take the whole numbers out and not get these gigantic improper fractions, right? Because if you made this into an improper fraction, we'd have 13 over 5, not too bad. But this one over here, 7 times 12, 84, plus 4 more, 88 over 7. Those are some big numbers to work with.
Yeah.
With the way you did it, we didn't have to worry about those big numbers quite as much. I like that a lot. Really well done.
There you go. Nicely done on that. And for working out such a great problem right there, we'll be awarding you the pass to Maya Cinemas. So you can go check out a movie of your choice over there. Do you have a movie in mind?
The Grinch.
There you go. Why not? For the holiday season, and maybe go on the same night. You go see Holiday Lights, go out, get a meal somewhere, and make a night of it. All
right.
courtesy of Do the Math.
Hey.
All right, erase the board. You're on a roll. Let's get working again. So you know how to multiply fractions
Yes.
with whole numbers and mixed numbers and things like that. So now let's divide.
Okay.
All right. So I'll come up with the first one. All right. Well, you know what? Let Scott come up with the first one.
Okay. Let's do 3 and 2/3
Divided by.
divided by.
All right, Wyatt, what do you think?
1 and 1/2.
1/2. Ooh, we got some interesting things here. Now, the question of the day is: are you going to take this apart like you did the last one, or are you going to change them all into mixed or improper fractions?
So we're going to do it into improper fractions because there's a very important step that you have to do with the fractions.
Okay, so let's do that step first. Then let's see if we can change these to improper fractions.
So in order to make a mixed number into an improper fraction, you have to do the whole number times the denominator. 3 times 3 equals 9, plus the 2 equals 11 over that 3 that was
Good.
up there.
Good. So we have the same denominator here as we do
Right.
there. Right. So even before you start the second one, we could do this, right? We could just go ahead and put the denominator in there right away. Okay, good.
And so now 1 times 2 equals 2, plus that 1 from before equals 3.
Good. And we still have a division sign here.
Right.
Now what do we do?
So the step is that, the important step is we're going to switch these two around. So now it's going to be 11 thirds divided by 2 thirds.
I like what you did there. Tell me about flipping this over. And do you have a name for it? It's one of those math words, huh?
Right.
Reciprocal.
Reciprocal.
Yeah, it took the reciprocal,
Right.
but you changed this, and it looks to me like you still have a division problem. Now what do you do?
So now what you do is, instead of dividing, since we already flipped this, we're going to
Oh, gotcha.
multiply.
So the only way you can change it to a multiplication problem is if you flip over the
it,
second one.
right.
That's it. Okay, so now we have a problem we can do just like the last one. Off you go.
So now it's 11 times 2, which equals 22. And 3 times 3 equals 9.
Good. And if they said leave it in improper fraction form, you could leave it.
Right.
But we never say that.
Yes.
So let's see what we can do with 22 over 9. It's a hard one to see.
Okay, so now, how many times does 9 go into 22? 9 goes into 22 twice. There's your whole number.
Okay.
And
And
now,
we still are going to have a fraction with 9 in the bottom.
that's correct.
So I always like to remind my students, always keep that same denominator when you're doing the division or whatever it happens to be. Okay, so we still have the 9 there?
Yes, and so 9 goes into 22 twice. 9 times 2 equals 18. And so we're going to take the numerator still
Uh-huh.
and subtract it by 18.
Good. Yeah, you're good. That's all right.
So we're going to go over here and borrow 1.
Mm-hmm.
And this one becomes 12.
Yep.
And 18, or 12 minus 8 equals 4.
4. Can I put that up here for you?
Yeah.
Look at that. 2 and 4 ninths. Now, just to make sure, do we have any units to put in there? Inches, feet, centimeters, yards?
No.
Nothing. But if we
That's
did,
it.
we want to make sure to put it at the end.
Very good.
Good
Erase
work.
the board. I've got an exciting problem for you to do.
Here we go.
Yay.
One more.
All right, Scott, on the left-hand side, I want
Yes.
you to write these vertically.
Okay.
4 and 5/8.
4 and 5/8.
Underneath it, 0.481.
0.481.
Underneath that, 4.75.
4.75.
And after that, 40%.
40%. All right.
Now, Wyatt, I would like you to take all 4 of those and put them in order on a number line, least to greatest.
Okay. So,
Are they all bigger than 0?
yes.
Okay. So there's your
And
0.
you've got 3
Okay,
minutes.
zero. Okay, so since we know that this and this are both under 1 because there's no ones place, and this is not 100% yet,
Okay.
these two are both have whole numbers, meaning that they are both bigger than those.
Okay.
And now we're going to find out, since
1, 2, 3, 4, 5. So you talked about these two first. Tell me the area where you think they're going to end up on the number line. Where are they going to be? You said they're less than 1?
these two, since they are less than 1, they're going to be right here, these two, because they are going to be
Less than 1.
Yes.
Right.
Oh yeah,
Gotcha.
right here.
Right there. Gotcha. Somewhere in
Less
there.
than 1.
What about these two? Where are they going to be?
They're going to be way up here because they have a 4 in them.
Gotcha. So your job now is to figure out which of these is bigger between the two and which of those is bigger between the two.
Okay.
Can you make this into a decimal?
Yes, you can. All you have to do is you just have to, since there's a decimal here, imaginary decimal, you just move it over twice,
Okay.
and you have 0.40 or 0.400, so you can compare.
Gotcha. So is 0.400 bigger or is 0.481 bigger?
0.481 is bigger.
Gotcha. So what's the smallest number of all 4 of those?
that one right there?
Gotcha. Where are you going to put it? That's a pretty good spot. 0.40. Okay. What about this
Okay.
one? Where does that one go?
That one's gonna go right about.
Let's make it pretty close. There you go. Yeah, make it nice and close.
I'm
They're
gonna
pretty
go
close. Kind of hard to squish them all in there.
I was going to say, you could write it underneath if you wanted to. It doesn't all have to be on top, but
I like that one.
That'll work.
I like that little line going in there. Good. 0.481. I'll help you out with that one. Okay, now we got to figure out which one's bigger, 4 5/8 or 4.75.
So what I do is, since I know that that 75% is out of 100, we're gonna make this one out of 100.
Okay.
We're gonna try to make that out of 100.
All right.
So
So to help you out, I'm going to tell you what that's going to be equal to. So 5 divided by 8 is going to be 0.625.
Ah, so we can make this
Simply because you've got about 40 seconds left.
625. Look
Okay.
at that. So
So-
which one's bigger?
that one, because it
Gotcha.
has
So
a
that's
7.
going to go the furthest down. Go ahead and plot 4.75. Yeah, there you go. And this last one we're going to actually write as 4 5/8. So don't write 4.625. Write down here at the bottom. Put down where it is. 4 5/8. 4, yeah, and 5/8. That's a tough spot over there on that board, isn't it?
Well, if it needs to go higher, by all means, put it up higher.
There you go. Good. 4 5/8. Show us where it goes. Can you stick a little line that goes right before that one? Maybe. Yeah, somewhere around there.
Right there.
Nice job. Well done. Really
There
well
you
done.
go. Under pressure comes through like a champion right there. I had to give you something with all 4s in there to make you think a little bit, but I do appreciate the way you reasoned with where they're going to go basically and then work from there. So
Right.
nicely done. Hey, we do have one more opportunity to go out to COM and visit with Marylou.
We are live here at COM, and guess what, Mike? I get a sneak preview of Holiday Lights. Can you kind of tell us everything that's going on here? How long has Holiday Lights been here at COM?
So this will be the 16th year of Holiday Lights out here at COM, and there are millions of lights. It's going to start November 30th, so the public can start coming out, and it'll run through, I believe, January 5th And what it's going to be is starting about 5:30 every night. You can come out and see the lights. There's going to your ticket into the zoo will get you a carousel ride. It'll get you a train ride. There will be food and drink that you can buy, and then you can just walk around and look at all the lights.
So is there other activities besides the train? Any other activities that people can do as they're walking around?
Mostly there is going to be the train ride and the carousel, but there will be some exhibits open. So the reptile house will be open. That's usually a favorite because it's 80 degrees in there all the time. So when it's really cold outside, it's nice to step in there if you're not terrified of reptiles. The other thing is we do have some of our exhibits open. So one of our owls, his name is Draco, he's on exhibit during the light show and he hoots at almost everybody that goes by. We'll have some long-eared owls that are also on exhibit, and the cat exhibit is open, and occasionally they do come down at night and sit right by the windows to get a close-up view at night of the cats.
But all the other exhibits, will there be barriers up showing that they are closed to the public?
Yes, most of the rest of the exhibits will be closed. Many of those animals are nocturnal, well, not nocturnal, they're diurnal. They're going to be sleeping at night, and we don't want that many extra people coming through and disturbing them. The lights don't go back through all the zoo, so we also keep that portion of the zoo closed because it gets very, very dark out there.
And the coast room, that will be closed, Andrew, yes?
Yes, closed for holiday lights. So it open during the day.
Okay, so working out here, how long have they been working on the lights, setting up?
That is a good question. I think they came out about the beginning of September, maybe the end of August, and they start setting up the lights at that point.
So how does that affect the animals and also you guys, the workers?
It is actually 16 years in, we've gotten about working around each other. So sometimes they're in our way, sometimes we're in their way, but they have these giant lifts that they drive around to put the lights up, and so we've just gotten really good about working around each other, blocking paths, keeping paths open for each other, making sure we're all being able to get done what we need to get done.
And where do all the funds come from? Or well, I should say, the money that you collect from everyone coming out here, what does that go to?
So this is one of our, I think it is our biggest fundraiser of the year, and all the money goes right back into Calm. And so we're able to do new exhibits from the funding that comes in through Holiday Lights.
Like the Coast Room.
Like the Coast Room. I believe Cats of California was also mainly funded through Holiday Lights as well.
Well, it's absolutely beautiful out here. As you know, as dusk comes, it's beautiful. And again, Andrew, thank you so much for showing us around today, the Coast Room. So much fun. Y'all need to come out, do the tank, try it out, touch everything you can in there. And this is from us. Again, thank you for showing us around today. There you go. Thank you, Sharon, again. Always fun. This is not it for us for Calm. We have a couple more that we're going to be out here, I believe 2 more times next week, and the following week we'll be back out here. But remember that it opens this Friday, so come on out here. It is actually beautiful. Back to you at the studio.
That Marylou, and as she said, it opens up this Friday, and if you'd like an opportunity to head out to Holiday Lights at Calm for free, all you have to do is give us a call and do the math. We have phone tutors available until 5:30 most Tuesdays and Wednesdays between now and those next 2 weeks. And until we meet again, hey, you know what? Did you have fun today?
Yes.
You did an awesome job. And one of the things I really appreciate is your use of mathematical vocabulary, using the proper words instead of just the number on the bottom.
Yeah.
Saying denominator and things like that. So well done. So we appreciate Wyatt coming in. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.